So this might not be easy to explain, but I'm going to try. First off, we set this up. We found that if you're pumping gas out of this cylindrical tank, basically every tiny little bit of gas that comes out removes one rectangle. Now, the length of the rectangle is 12. The width of it just happens to be 2x. Wait, how do we get 2x? Well, if we write an equation for a circle, that's x squared plus y squared equals 25 fourths. And we realize that the distance from the x-axis over to the side is x. The length of this entire red line would be 2x. And let's be honest, the length of that entire red line is the same as the width of our little rectangle up here. So we took this equation, we solved it for x, and we got the nice square root. In green is what we had last time. This is what we had written out as our final integral, and it is correct. I just wanted to show that I took this exact same integral, recopied it up top. All I did is I took 42 times 12 times 2, and I made that 1008 because that's what my calculator said it was. So I'm going to remove this from the way, and let's talk about how we can solve this integral. The only reason I'm taking a moment to do that is because, well, it's kind of interesting. So imagine we do this. Let's just go ahead, take 1008 times 19 halves. What I'm going to do is I'm going to distribute this, and I've got that nice little square root there times dx minus, and then down here I'm still going to have 1008, but times the second half, which is y times the square root of 25 fourths minus y squared dy. I know I didn't put the limits in. Just pretend they're still there. Okay. What I want to point out is that all I did was if I can do this in any nice form, I took this square root times 19 halves, and I took it times negative y. So I just distributed it to those two terms there, and I made it equal to two different integrals. Now here's the funny, fantastic, really wonderful kind of part. Because we're going from negative 2.5 to positive 2.5, or negative 5 halves to positive 2 halves. And guess what? This portion, when you take y times that square root of a number minus y squared, believe it or not, that is an odd function. That entire integral right there, because it goes from negative 2.5 to positive 2.5, it's an odd function. That integral there equals 0. And guess what? I have a shortcut for you here too. When you're integrating this, isn't that just the integral of a semicircle? Instead of integrating in some hard way, can't we just say a semicircle is pi r squared divided by 2? Yeah, I know. We have this other stuff in front. We had like 1008, and we had a 19 halves. But essentially, we're looking at this. The area of the semicircle times 1008 times 19 halves. That makes this a much easier problem to solve. I'm not even integrating. I'm using geometry for the top integral, and I'm using symmetry for the bottom one. By the way, that is 1008 times 19 halves times pi times the rate. Oh, what is the radius? 5 halves squared over 2. And I think the final answer ends up being something to the effect of about 94,012.16 foot-pounds. It's quite a bit of work. It is. But it was mainly the setup. What shape is the increment up top? How do you get it using a formula? And then just integrate your work formula. I hope you enjoyed this video and it makes some kind of sense